to take notes?
We don't even
They have
have
like 10 minutes.
We could get a lot done. All right. We're continuing with the synthetic division that we did last week that last 2 days ago. You guys did this last year in Math 3. So again, still review. X equals -4 is a solution of x squared minus 28x minus 48 equals 0. Period. Use it to help factor completely. All right. So we're going to use synthetic to help us factor. Let's take a step back and look at the problem given. This one right here. What is the degree? 2. To make sure I wrote it down right. Which means we have how many solutions? 2. Do you guys agree? How many did they give us? They gave us 1. They want us to use synthetic to help us find the other. Got it? All right. So what goes in the box? When it was like this, I told you guys to set it equal to 0 and solve. And when you do that, you get x equals 4. This one has already been solved for you. Do you see the difference? This one has already been solved. So what goes in the box? -4. All right. Okay, there was something wrong, and I knew there was. Right here, it's something small. That degree is going to change. We're going to put that as a 3. All right. So if you will please make that change, x cubed minus 28x minus 48. Because the degree is 3, how many solutions? 3. How many did they give us? How many more do we need to find? 2. All right. Remember we talked last week about needing zeros in there. I'm going to put a little arrow this way. If this is x cubed and there is no x squared, I would put 0x squared. All your x's need to be accounted for. Third power, second power, minus 28x to the first power minus the constant. Third power, second power, first power, no power. All they need to all be there and in order. So what are my coefficients that I'm going to write down? 1 and then 0, negative 28 and negative 48. All right, do you guys remember how to do this? Yes?
Would it be 0x squared instead of 1x squared?
Because 1x squared means there is an x squared in the problem. And it has a value of 1 because there's 1 of them. This here has no x squareds. No x squareds means none of them exist, so it has to be 0. 0 because there are none. Putting a 1 means there is an x squared and there is not. Good question. What?
That's our band.
Your coach all right. So you drop down the 1. And what do we do with the -4 and the 1? And -4 times 1 is -4. What do we do with the 0 and the -4? Add. And then we do what again? Multiply, which is positive or negative? Positive 16. And what do we do going up and down? Add. Negative 28 plus 16 is, and then do I add or multiply? Positive 48, add, and I get 0. I put that line there because that last piece is my remainder. And it tells me a few things. Right now, it tells me that my remainder is 0. Now, that should make sense. If this is a solution, should the remainder be 0? Yes. If this is a solution, meaning x plus 4 is a factor, then the remainder should be 0. Got it? All right, do you guys remember what we do? The degree is 3, so what do we do here? We go 1 degree down, so this would be 1x squared minus 4x minus 12. And what can I do with the x squared minus 4x minus 12? I can factor. I don't have to use synthetic again. We will do that eventually, but right now we can factor. It said here, use it to help you factor completely. So I'm going to write y equals, because they wanted us to factor this completely. Okay, what is this first two? What is, I'm going to cover that last piece. What is that x squared minus 4x minus 12 factor to? X plus 2, x minus 6. Does everybody agree? No, I just automatically put that extra parentheses there. Can anybody tell me how you should know that this is not done, that there's more to it? What is the degree here? Right here. What is the degree? 2, but the degree should be 3. What do I put here in the last parentheses? X plus 4. Good job. Don't forget that. Some kids often forget that root, the answer that was given to them. They forget to put it in as part of the solution. Yes?
I got confused when you wrote x squared minus 4x minus 12.
How I got it?
Yeah.
Can anybody answer that? How we got the x squared minus 4x minus 12?
Aren't you supposed to do one less of every x that there is?
One less of the degree. Oh, you mean from, like, in order here?
Yeah, so the x cubed would turn into x squared, the 28x would turn into 8.
You, okay, you go off the first one. What's the degree?
X is
3. And 1 less of 3 is 2, and then you just decrease thereafter. So 2, 1, constant. If there are any zeros, the zeros would pop up in here if we need to put any zeros anywhere. So 1x squared minus 4x minus 12. So I use these numbers as my coefficient. 1x squared minus 4x minus 12. 1 less than 3 is 2. Second power, first power, no power. I just decrease going down.
So if it was 4, it would just be
3. Then it would be third power, second power, first power, no power. There'd be one more number if it had been to the fourth. Okay. Got it? Okay, number 2. Actually, we're going to graph. You can leave the 2 there and call it 2, but we're going to graph this one. Do we have enough tools at this point to graph? Yes? All right. Let's take a look at end behavior. Take a look at end behavior. Like high-low business. What's the degree here? Degree is 3. Is it positive or negative? Positive. What does that mean about our end behavior? Low, high? Everybody agree with that? All right, what's the next thing we do? Find our zeros and the y-intercept. All right, 0 equals x plus 2, x minus 6, x plus 4. Are any of these have a multiplicity of 2, or are they all multiplicity of 1? All right, so I'm just going to list them. X equals negative 2, 6, and negative 4. Bye-bye. Enjoy your weekend. All right, everyone see that's negative 2, 6, negative 4? Yes? All right, and the multiplicity is 1, so they're going to cross or bounce on all of them. Cross. They'll all be crosses, cross, cross, and cross. All right, now Maddie pointed out we also need to find the y-intercept. Y equals 0 plus 2 is 2, 0 minus 6 is negative 6, and 0 plus 4 is 4. All right, so go ahead and work that out. Remember, you find the y-intercept by making all of your x's 0. 0, 0, 0. Anybody have it? Thank you, negative 48. All right, anything else to find, or is that it? Is that it? All right, so I have an intercept at negative 2, positive 6 and negative 4. And I have a y-intercept at negative 48. Okay, so and they're all crosses here. So let's take a look. I'm going to start low, cross. I don't know how high up I go, but I know I have to come back down. I don't know how far, well actually I do know how far down I could go. I go far enough to hit a y-intercept of what? Negative 48. You don't have to draw it to scale or put 48 tick marks. Then when you come back up and hit the 6, anything bringing us back down, or is that it? That's it. Low, high. Now, really quick side note, sometimes kids will get this messed up and call it positive 48. When you're graphing, is there any way for us to have a positive y-intercept? No. And I will have kids on the test like do wonky things, like they bring it back up anyway. There is no way for me to get from here back up there without hitting another y-intercept, which does not exist there. Do you see that? So pay attention to this. Like if you end up with a mistake, go back and fix it. You know there's a mistake if you end up on the wrong side and your intercept's on the other side. Yes?
Are there going to be any balances?
Yes, yes. We did have bounces when you weren't here, but there will be bounces. There was one of them there. But you do remember that from last year, yes? Okay. All right, questions on number 1.
When you're solving for the y-intercept, can't you plug 0 into the original equation?
Yes, good observation. She said, what about if they do give you an original, which they did here, and let's call this y, would it be easier to plug in 0, 0 minus 48? Yes, it would be. Good observation. So yes, if they give it to you in expanded form, is always easier to find your y-intercept. So if it ever is an expanded form, plug in 0, 0, and then your last number is your y-intercept. Got it? All right. Number 2. F of x equals 3x cubed plus 2x squared minus 19x plus 6 2 factors are x plus 3 and x minus 2. And there's more to it. I'm going to let you write down that part first. Okay. I'm going to, if I asked you to graph this right now, this top one, would you have enough tools to graph? No, you'd have enough tools to figure out high-low or low-high business. Other than that, do we have the tools to factor this? No. All right. So they gave us 2 factors. How many more do we have? 1 more. And again, even given these 2, it's still kind of hard to find the third because we don't have tools to factor this kind of problem. So we're going to use a synthetic division to help us find it. All right, so part A, find the remaining factor. Part B, write out in factored form. And part C, list all the zeros. All right, so they didn't ask us to graph, but we're finding pretty much all the bits and pieces that we would need to graph. All right, how many factors did they give us? 2. I will tell you right now, it does not matter which one you use. It does not matter which one you use. Pick one. You want to pick the 2? And when I put it here, is it 2 or negative 2? 2. Now, I would challenge some of you guys to try the negative 3 if you think you can handle it on your own, just to see if we end up in the same place at the end. Third power, second power, first power, no power. Are all the x's accounted for? Yeah. So that's 3, 2, negative 19, and 6. Because we're using factors, should the remainder be 0? Yeah, I'm going to put a 0 right there because I know it should come out to be 0. Go ahead and work it out. I'm going to let you guys figure out your numbers knowing the last one should be 0. Did it work? All right. So let's see. This is 3. What's the next one? 6, and then 8, and then 16. And negative 19 and 16 is negative 3, and that is negative 6. And did it work? All right. So what do? We take 1 power less. Third power, what's 1 power less? Squared, so this will be 3x squared plus 8x minus 3. Now, once it's to a degree of 2, do we have the tools to factor something that's squared? Yep, so do your double bubble. This is a guess and check where you have a leading coefficient other than 1, so 3x and x. And we've talked about this before. The only factor of this last term is what? The only factors of 3 are what? And we've talked about this a ton of times. Save your time. Is that even a guess you should waste your time with? Why not? This has a GCF. Don't waste your time. So there's really not a lot of guessing here. This has to be 1. This has to be 3. The only thing you have to work on is which one's plus and which one's minus. Let me know when you have it. Positive 3, negative. Positive 3, negative 1. Sorry. All right. Positive 9, negative 1. Does it give us the positive 8? All right. Did anybody use the negative 3 instead? No? Yes. Does your answer look different here?
Yeah.
Yes, and it should be, but here in the end we're going to have the same answer. All right, part A, can you tell me what you ended up with? I'm going to put your answer over here. When you factored this, when you did this and you factored, what did you end up with?
I got 3x minus 1 and then x minus 2.
Perfect. All right. So let's take a look at what we have, what she has, then we're going to compare. Two factors are x plus 3 and x minus 2. Find the remaining factor. We used the 2 here. Did we get the x plus 3? Should we end up with that? Because it is a factor. Because we didn't use it, it comes out. Now she did use this one, and what does she end up with as her second factor? The one that she didn't use. Will that always happen? Yes. So we used the 2, and in our factored form, we ended up with the x plus 3. She used the x minus 2, and or the other one, she used this one and ended up with the x minus 2. Got it? Okay. Now, what they're asking us for is the remaining factor. In both of these, which one is the remaining factor? And you see that it's a 3x minus 1. And did she get the same answer as we did? Yes, the work looks different in the beginning, but in the end it's still the same. 3x minus 1 is the remaining factor. Does that make sense? All right, part B, write in factored form. Y equals, or f of x equals 3x minus 1. And what are the other two? Good job. She said x minus 2 and x plus 3. The order in which you write them does not matter. Part C, write your zeros. List all zeros. How many zeros do we have? 3. First one is positive 1/3. Next one is positive 2. And my last one is negative 3. Questions? None? All right, number 3. Before I write it, I'm going to write up here rational root theorem. Now, I'm not sure if this is something you've seen before. I do not think that it is. Rational root theorem. And I'm going to show you how to do it by just giving you an example. List all possible rational roots. And this is a test question, by the way, just listing the possible roots. We will learn how to go past just listing them, but for now we're just going to list. All right, f of x equals 2x to the 5th plus 4x squared plus 15. Two x squared, 2x to the 5th plus 4x squared plus 15. All right, are we ready? Okay. First off, you want to make sure that it's in descending order, highest power first and going down. We don't need to put zeros in there as long as it's in order. 5th power, 2nd power, no power. Is it in order? All right, highest power first, the constant at the end, or lowest power last. I'm going to call this first one Q, the coefficient Q, and this constant P. And the way we find our possible roots is by working with factors of P over factors of Q. I'll explain what that means as we go. Factors of P over factors of Q. Factors of the end over factors of the beginning. Now what this tells us, how this helps us is over here in the last two problems, I kept giving you factors to work with. What do you do when you will have a test question where no factors are given? You just have to randomly guess. Yes, you have to randomly guess. Now there's an infinite amount of numbers to guess from. So the possible rational root theorem eliminates a lot of the guessing and narrows it down so we're not doing an infinite amount. The list may still be big, but it's not as big as just randomly pulling out numbers from nowhere. Got it? All right, so here is how it works. We're going to find the factors of P and the factors of Q. Let's work with this one first because it comes first. What are the factors of 2 in order? 1 and 2. What are the factors of 15 in order? 1, 3, 5, and 15. All right. Factors of P over factors of Q. I will take, the way I do it, I take all of these and divide by the first factor. And then I take all of these and divide by the second factor. And if there was a third, I would take all of these and divide by the third. And I will tell you, it is always plus or minus. I'm going to do that first. Plus or minus. Now, 1 over 1, 3 over 1, 5 over 1, 15 over 1 is just 1, 3, 5, and 15. Do you agree? How did I get that? If it helps you, you can go ahead and put them over 1 so you know where they're coming from, but eventually we will not write the over 1. I took all of these because I'm taking the factors of P and dividing them by the factors of all the factors of Q. Now I'm going to go again, and now I'm going to, I already finished the 1. I'm going to work with the what? 2. So it'll be 1 over 2. What's the next one? 3 over 2, 5 over 2, and 15 over 2. Now, students are going to complain, oh my goodness, those are a lot of numbers and there's fractions. But again, this list is a lot better than just randomly guessing from nowhere. So that means all the possible solutions for this set are coming from this list of numbers, plus or minus. So positive 1, positive 3, positive 5, positive 15, blah, 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 and all of the negatives as well. 1, 2, 3, 4, 5, 6, 7, 8 times 2, so there's 16 possible roots. Now, are all of these going to be roots? No, how many am I going to have? 5. But those 5 will definitely come from this list of numbers. Some of them might be double roots, which we'll address eventually. So I'm going to come up here and see if that happens. I'm going to come up here. We know our roots were 1/3, 2, and -3. And I'm just going to quickly see if we can get that. What are the factors of 6? 1, 2, and the factors of 3, 1 and 3. All right, put all of those over 1. What do you get? 1, 2, 3, 6, and then all of those over 3. Don't forget the plus or minus. What is that? 1/3. What's the next one? 2/3. The next one? 3/3 is 1. Do I already have it? I'm not going to write it again. And then 6/3 is 2. Do I already have it? I'm not going to write it again. You can. All right, our solutions came out to be positive 1/3. Is that part of our list? Another answer was positive 2. Is that part of our list? And the third answer was -3 with a plus or minus. Is that part of our list? Yes. So your solutions will always come from the list of possible rational roots. Got it? Rational root theorem. All right, so you will have test questions where they will just ask you for this, and you'll just give me that list down here like this, and that's it. And there will be some, like this next one here, where you have to find solutions. And instead of randomly guessing, you use your rational root theorem. All right, number 4, find all the roots of f of x equals x to the 4th minus x to the 3rd minus 29x squared minus x minus 30. All right, and we're going to go as fast as we can because we are running out of time. What are the factors? This one's nice. What are the factors of 1? 1. What are the factors of 30? A little bit more. 1 comma 2. Does 3 go into 30? Does 4 go into 30? No. Does 5? 6, 7, 8, 9, 10. What's the next one? 15 and 30. All right. Luckily, there's no fractions, but guess what? You may have some in homework tonight with fractions. You work with them just like you would any others. All right, so these are all plus or minus 1 over 1, 2 over 1, and so forth. It's just going to be 1, 2, 3, 5, 6, 10, 15, 30. Do you agree?
Yeah.
For all the possible rational roots. All right, so we're going to take from this list and make guesses. How do we know if it works? If our last number is what? 0. If it's a root, the last number should come out to be 0. All right, 4th power, 3rd power, 2nd power, 1st power, constant. Are they in order and all there?
Yeah.
Okay, so 1, -1, -29, -1, -30. All right, give me a number to try first. A positive or negative, I don't care. 2. Let's try the 2, and then I'm going to let you guys try on your own later. 2 times 1 is 2, -1 plus 2. Before I go further, was 2 an okay number to guess? Should I guess a number like 7? No, I'm wasting my time. It's not in my list. All right, let's continue. 1, 2, 1, and the next number is 2. Next number is going to be negative 27. 2 times negative 27 is negative what? And that's going to be negative 55, and that's going to be negative what? Is that going to give me 0? I can stop here. I could have stopped over here if you could tell it's not going to work. What is that, negative 140? The last number needs to be 0, so is 2 a possible solution? No, you should keep a list, maybe crossing them out somehow, or a list of didn't work. You don't want to keep trying a number if it's not going to work. All right, I'm going to give you one that does work, 6. But I will tell you right now, you would be guessing these until you found one. All right, so do the 6. Mm-hmm.
How do we know if we need to do this part with the synthetic? How do we know?
When you're doing rational root theorem, if it says, if it's asking you for zeros or find the roots, you're using the synthetic. Did it work?
Yeah.
All right, 30, what is that? 1, 6, 5, 30, and 0. Yes or no? All right, and then we're running out of time. I'm going to give you some time to guess, but I will tell you this. Your next guess will be made off this new set of numbers. Do not go back to the beginning because you're just going to make it harder on yourself. So your new guess should be made with this set of numbers. Could you use 6 again? Could you try it? I'm going to put 6 over here as it worked. Could 6 work again? Yes, because it could be a what? A double root. If it doesn't work, then you try other numbers until you get it down to where you find all the roots. And how many are there? 4. Technically, you just have to get it down to what power? To the second. Because once you can get it down to the second power, that's when you have 3 numbers here. Once you get it down to that power, what can you do? You can factor. Does that make sense? All right. Questions? Yes.
The way you know how many roots you have to get is like if it says x to the 4 or x to the whatever.
Yes. So the degree will be the number of solutions or roots you'll end up with at the end.
Okay, so then you have to figure out all the numbers you have out of the 4.
Mm-hmm.